So let's start with the overview of Chord. So I'm going to start with a slide that really almost tells you the whole thing, and then we're going to walk through the pieces and kind of build back up to it. So this is kind of an overview in a couple of bullets about what we're going to talk about. So number one, it's that the network edge is undergoing a huge transformation. This is the edge of the operator networks, and this represents a huge opportunity, both for operators to transform their networks and deliver new services, and also for vendors to be able to supply this infrastructure. We're talking about $300 billion a year of infrastructure going into this space. It's massive. It's a huge, huge, huge opportunity. So Chord has emerged as a compelling solution for this network edge. And we're going to, of course, talk about today. But it's number one, it's leveraging disaggregation, open source, and white boxes. So disaggregation is the result of SDN, breaking the network into pieces to enable innovation. Then open source software, of course, and then white boxes, really a new supply chain to be able to start thinking of these boxes almost as peripherals that can be used, and then common software that can bring it all together and orchestrate it for you. It puts SDN, NFV, and cloud technologies together. So this is really the fundamental of what Chord is about, to end to a compelling solution. So rather than giving you a bunch of piece parts you need to put together yourself, Chord puts them together for you. There's a distribution you can download and bring up and run. Then you can customize from there. But rather than starting with a bunch of piece parts and you need to figure out what to do, Chord is getting this fantastic success because it actually assimilates all of it together, makes it sure it's working together, and gives you something that's kind of a unified whole. There are now many service providers experimenting with plans for trials and deployment, and I'll talk about some specific names later. And then we also have a vibrant community, and over 60 companies now contributing to Chord. And so this is an open source project. We have at the ONF over, I don't know what the number is now, over 165 members or something like that. I talked about the 8 operator partners. We've got another 20 operators that are working with us. We have vendors, we have system integrators, we have chip companies, you name it. And so it's a very vibrant ecosystem that is really driving the transformation that we're talking about. And as a result now, Chord has now demonstrated support for the 3 major use cases at the edge of the network, and that's for residential, mobile, and enterprise subscribers. So I'm going to give you a high level of that now, and then later on we have sessions on each of these to talk about the details of what Chord does and how it provides and how it addresses the issues for each of these use cases. So let's talk about the edge. Why the edge? Why is it so important? So I apologize, we're in Europe and I'm using a picture of America, but this is the slide that I had. That it's the case that often when we think about the operator network, we think about the core network. We think about the big picture and top down. But the title of this slide, where do service providers face challenges, and where do they spend their money? It's not in any of this that you see here. Really, it's at the edge. That the reality is that the backbone is a relatively small part of an operator's expense, and really, requires a relatively small amount of their attention. It's actually relatively simple compared to the majority of the network. The edge is where 80% of their spend is, where the majority of the complexity is, and that's where they have all their, the resources out. So, if that backbone has 50 sites, that operator might have 5,000 edge sites or central offices. Now think about that, 50 versus 5,000. That's 2 orders of magnitude. And so the complexity at the edge is astronomical compared to the core, but it's also where the opportunity is, because that's really a unique asset that these operators have, is this points of presence close to the subscribers out at the edge of the network. So that central office is, today dated legacy equipment. These things have been around for decades and decades. They have 300 plus different types of equipment, each specialized box that does this or that. That's a huge source of CapEx, and even worse, a huge source of OpEx. And it's very hard to deploy new services. And today, you buy a new box or you do something new, it's a nightmare, to be honest. If you've ever been into a central office, you'll know what I mean. It's not a simple environment. And yet, at the same time, it's a huge source of opportunity, if you think about it. This is where the operators connect to their customers. And, of course, where you connect with your customers, your most important asset. So the CO is the gateway to the customers. There are thousands and thousands and thousands of these COs, even in an operator, and many more if you think about all the operators around the world, of course, and then the end user experience is controlled by this facility. So it's an incredibly important asset, and it's a unique asset for these operators. So, the cloud, there are really multiple types of clouds, almost a tiered cloud architecture that's starting to appear. So, we're all familiar with the commodity clouds, the Amazons of the world. These have huge traction and everybody knows what they are. The telcos are starting to deploy their own clouds or specialized clouds for deploying services as well. And then we have the central offices that are out close to the users and the subscribers. And so the first part of our vision here is to replace these central offices and to turn them into edge clouds, to make it part of the cloud architecture, to bring all the best of cloud-like thinking to the edge of the operator network, to get rid of those 300+ different boxes and make it a uniform white box architecture that's nimble and easy to deploy, easy to manage, easy to deploy new services upon. So this is core to our vision and thinking, is this edge cloud concept, and Chord is all about that. And there are a bunch of things about this edge cloud to consider. So, we already talked about the subscriber experience is dictated from here. So that's one of the reasons the edge cloud is so important, But, think about all the next generation applications that we're talking about. And you're going to hear about them this week, I'm sure. There's virtual reality, augmented reality, IoT, all of these things. What they all have in common is that they need to be served from the edge of the network. And it really comes down to physics. So human reaction time is less than a quarter of a second. So if something takes longer than a quarter of a second, you'll notice it. Your brain will be able to perceive it. And think about augmented reality, for instance. Now we're talking about being able to, you have your glasses, and you're going to put the name of a building as you're walking down the street, and you want to be able to see that name. But as you move your head, that name has to stay dead solid on that building. If it moves with your head as you move, you're going to get nauseous. The application's not going to work. And the latency to talk back to the core cloud and back, that alone blows your budget to be able to build that application. So unless you're going to put all the compute resources into a set of eyeglasses, those compute resources have to be at the edge of the network, and that's where that's where it's headed. That's where things are going to happen, at the edge of the network. And so this is, just a good example of why edge processing is so vital for next generation networks. This is true for augmented reality. Think about autonomous vehicles. It's not about having your grandmother being able to take a car late in life when she can no longer drive. That's like a first order kind of thing with autonomous vehicles. Really, where it starts to make a big difference is when you can pack cars onto the highway. Imagine, the fast lane being all autonomous vehicles. They're all driving 2 inches away from each other. They're going twice the speed limit, and they're getting all the fuel efficiencies of a freight train aerodynamically. In terms of the capacity you can put on the highway, the efficiencies you can bring to society are tremendous. But that's, true synchronization of what's going on. If you build that, and one of those cars has a blowout, that entire chain of cars has to be able to simultaneously slow down and accommodate. And you don't do that by talking back to a core cloud and trying to negotiate that with big latency times. That processing has to be at the edge of the network. So these are applications that it's pretty easy to understand why edge processing is essential. But I'd add one more, IoT, because here's where most people don't realize how important edge processing is for IoT. You think of it as low data rates, and what does it matter? Well, if you think about a thermostat on the wall or some device, it's all battery powered. And the battery life of an IoT device is what drives the business case. If that thing dies in a year, no consumer is going to bother with it. It's going to be too complicated, and it really blows the business model. If this thermostat on the wall has to wake up once a day and talk to the core cloud, it wakes up, sends a message, waits, gets a reply, shuts down. Just that delay in talking to the core cloud will kill the battery twice as fast as whether it can wake up, shut down, talk to the edge of the network. By reducing the latency of the response time, you double the battery life of IoT devices. You double the business case for IoT. And so even IoT processing is likely getting pushed towards the edge of the network. And with Chord, we're talking about building an edge cloud that can accommodate dynamically all kinds of services in a very nimble, easy way and be able to support all of these applications. And that's why it's important. And that's why Chord has the traction that it has. So our mission with Chord is to enable this edge cloud concept, right? And so number one, it's about getting the economies of a data center. And what is that? I mean, that's, infrastructure built with a few commodity pieces, not buying specialized boxes, and using building blocks of open source software and white boxes. The next piece is to get the agility of a cloud provider. That's all about being able to deploy new services dynamically, easily, and rapidly. And all of this in an easy-to-consume platform. This is the key to Chord. The ease with which it can be consumed and the extent to which things are integrated is really what makes it unique and which is really driving the level of adoption that we talked about earlier, with 40% of all subscribers ultimately going to be running on Chord within 5 years. So what is Chord? So Chord takes all this legacy central office equipment, that mess of stuff, and rethinks it using the best of SDN, NFV, and cloud technologies to build a cloud-native data center for the edge of the operator network. So the hardware looks like a data center that we're used to. A spine leaf fabric, general purpose compute. But what's unique about Chord is, there's a unique requirement at the edge of the network that you need to connect subscribers into the network. They're connected optically over PON, or they're connected over wireless signals, and so you need some physical layer connectivity for those subscribers. And Chord provides that in being able to connect, let's say, business customers with Metro Ethernet, or wireless customers, or residential customers with PON. So it's part of the Chord architecture, but Chord simplifies those boxes as much as possible. And also, there's a piece to connect to the carrier's backbone with colored light, and integrate ROADMs to be able to, and wave division multiplexing to be able to bring in lots of bandwidth to these edge sites. So the first thing is, we simplify that edge equipment as much as possible. So it used to be a vertically integrated chassis that was used to connect subscribers over PON. Now it's a white box. With, yes, it has optics in it, but it's simplified as much as possible, and all the control software is extracted from that box and it's run in the cloud as applications. And so for each of these applications then, Chord also includes all of the VNFs is the term that the industry uses, and we'll talk more about our view on that, but it's the virtualized network functions, all the components, all the services are included in Chord. This is included today in distributions you can get. So you can get a distribution of Chord for mobile that includes full virtualized RAN all the way through a virtualized mobile core. You can get an enterprise distribution, and you can get a residential distribution that also has all of the services needed, all the VNFs needed, all the components needed to be able to deliver services to residential subscribers. So this is really what makes Chord unique. There's nothing else like it that's available out there. When you get started with Chord, you get all of this from day one. So I often describe it as, you can be given a steering wheel and some tires and an engine, and you can go build your own car. And yes, it's possible. Or you can get a car. Chord gives you a car. You can customize the car. You can change the wheels. You can paint it. You can add seats. You can do whatever you want to it, but it's much easier to get started if you have a working car. And that's Chord's philosophy, is we pull a distribution together that's a working, complete solution, so it's very easy to consume and then customize. And we absolutely encourage customization. All of our operators customize it one way or another. Vendors come in and customize it, add VNFs, add services, add system integration services. There's a lot to be added. Chord by no means is an absolutely complete done deal right now. I mean, this is a huge space. It's really a platform for innovation, but it's open. You get something, that car that's working, and then you can go and customize it. So I talked about service provider traction. Here are just some names to give you a sense of kind of what's happening worldwide. And so, it is a worldwide phenomena. It's happening, in the Americas, in Europe, in Asia. These are, really, when you think about it, I've done a lot of startups in my day. You almost never start with the tier ones as a startup. You've got all these kind of little small customers, and you're working your way up towards the tier ones. These are like all tier ones. It's kind of crazy, actually, the level of traction and what we have going on. And they're all using different flavors of Chord, pieces of it, components, and putting things together kind of in their own ways here and there. Some using it more complete than others, but these are all different forms of traction. The traction is quite significant. I would say that the traction continues to grow on a monthly basis. We are a small nonprofit, we learn about new organizations using Chord all the time. And when we learn about it, it's like they've fired up a team of 40 people that are doing something. It's kind of crazy, the level of traction it's getting and how fast it's moving. And all of these are really at different stages, but it's all really in the POCs, lab trials, early field trials. This is a big move for an industry that takes some time to do things. This is not going to happen in 6 months, but we are, the freight train is moving, and it's moving in this direction, and there's broad consensus this is the way to do things as we move forward, and we're just seeing that across the board and around the globe. So let's talk about the differentiators and the value prop for Chord. So number one, we have a unique and strong partnership. The ONF, and then our partners and members, providers and vendors that are working with us, and then also this broad community that's continuing to grow. It's open source, it's free, you can come right in. We've eliminated all barriers to entry. There's not even any cost to start working with us. We have membership structures beyond that, but it's an open door policy, so we want this to be as broadly available as possible. Because again, we're not after making money, we're after transforming the industry. And we believe this is one of the pieces to do that. The other thing, the next thing is that it's an integrated solutions platform for service delivery, integrating all of these open source projects for you. Just like that car analogy, instead of getting a steering wheel and tires, you're getting a complete solution. That means we integrate, the SDN controller and Fabric, OpenStack. There are 50, odd open source projects that Chord pulls together and pre-integrates to be able to give you a working solution from day one. And then we now have, common platform. It is a common platform for the three most critical and most massive, use cases at the edge of the operator network. We're going to have sessions on each of these in detail. It leverages merchant silicon and white boxes, so it's really the best of the cloud ecosystem, if you will. And so it's not only servers and switches, those are the most obvious when you think about this, but it's also the access equipment and even the ROADM and optical equipment back into the backbone is moving towards white box. And so you're going to hear more about today and this week. There's a session on open access on Wednesday afternoon that I'm doing and Deutsche Telekom's doing, and I invite you to come and see more there. And then, it's designed to be customized. And so again, it's a platform, but vendors and operators can customize. You can add your own VNFs, and you can deliver solutions and differentiated solutions based on this platform. And we think that's part of also what kind of drives the market. And we are about helping others find new business models in this new economy. So this is all part of it. So that's kind of an opening on Chord. I want to touch on a few other topics today, kind of level setting. So the first is that open source is a complicated space. There's a lot going on. It moves pretty fast, very fast. I would say every 3 weeks there's something new going on. And so I'm in the middle of it, and I can see how much to be able to stay on top of it from the outside is not a trivial process. That's one of the things we try to help with our ecosystem, is help people stay on top of things. But there are two open source projects in particular, and I thought just setting context for how Chord fits in with those might help people understand how some of the piece parts all fit together. So let's go back. We talk about this tiered cloud, right? And so you got the edge cloud, the telco cloud, and then the Amazons of the world. So the first thing that's going on is that Chord has emerged as a solution for the edge cloud. We've already talked about that some, or at some length, and we'll talk about that more today. But in this telco cloud is a project called ONAP that, how many of you have heard of ONAP and know ONAP? About a third or a half, so, right? So ONAP is a project, a couple of things came together, but it's really focused on that telco cloud, being able to deliver onboard VNFs and deliver services from those telco clouds. And so we often get the question about Chord and ONAP, how do they fit together? What does that look like? What is the ecosystem? How's it resolving? And we're actually both, connected into the Linux Foundation and working together on this problem. And so, the view that's emerging on how the two fit together looks something like this, where ONAP is serving as the global orchestrator end to end. It's still orchestrating that telco cloud, as in the last diagram, but also it's now orchestrating the Chord at the edge cloud. And Chord has very unique capabilities. We already talked about a bit, and we're going to go into with more depth as this afternoon progresses. And But Chord, multiple instances of Chord are running out close to the users. And then Chord exposes a set of edge services to ONAP. So ONAP might say, oh, I want to turn on some kind of firewall back here. ONAP can also say, oh, I want to fire up a mobile subscriber. And then Chord inside here can actually do everything it's needed to bring up multiple little pieces to be able to craft a service for that mobile subscriber. And we'll be looking inside that in a moment and throughout the afternoon. And so Chord is an edge-optimized cloud with unique capabilities for the edge. It's around subscriber access. We already talked about the specialized hardware that's needed. That's one of many things. It's a real-time response and control. You're going to see, let's say, in M-Chord, that M-Chord is starting to break out the control of the RAN and being able to do real-time control and move users between different cells and whatnot. That requires a very quick response time, agile network at the edge of the network. That's part of Chord. It's one of the things you need to process close to the users. And then lastly, and I want to talk about this on the next slide, is a combination of microservices and fabric services. And this is a concept, and not a lot of people understand this. We haven't talked about it a lot, but it's something that's part of Chord today, and it's part of what makes Chord unique and part of what's really required to deliver services at scale at the edge of the network. This notion of a microservice and a fabric service. So let's talk about that. So first of all, when the whole virtualization craze took off a couple of years ago, everybody started envisioning taking everything out of a fixed function router and putting it on an x86, and that was going to change the world, and we're all very excited about it. But we have learned over time now that not all services should be run on a server, and that by moving things, monolithic things from a router onto a server hasn't really changed the world as was initially hoped. And so Chord has a couple of building blocks. So it has microservices and fabric service, microservices that run on servers and fabric services that run in switches. And the Chord builds a service graph chaining together these elements. And in so doing, you can build a chain where some things run on x86 and some things can run in the fabric itself. And by running in the fabric, it can run at much higher price performance ratios. It's about 100x the performance of something running on a server. So there's great value when you can push things into the fabric. And Chord does that. And our vision for Chord is to do a lot more of that as we move forward. And then, we've been talking about ONAP. And so then these edge services are instantiated and controlled here, but then the global orchestrator can actually give commands down to an edge data center, an edge cloud, to fire up or turn down, to scale out different edge services. And then, lastly, as the data plane becomes more programmable, and we have an announcement this week, and I'm going to talk a little bit more about it as well. And P4 is one of the ways it's now envisioned for the data plane to become more programmable. Even more and more functionality can be pushed into those fabric services. So even more and more functionality can achieve those kind of price performance benefits, and you can really scale the edge of the network in new and very exciting ways. So the Chord architecture, I'm not going to talk in detail, you're going to see more of this, but this is just an example service graph for residential service. And really what I just want to point out is, traffic comes in from a residential subscriber, it's headed out to the WAN. You can build a service graph to take the traffic through in different ways. And the things that are in red are running on a server, and the things that are in blue are running in fabric. And this is today, leveraging OpenFlow. And so this is really unique about Chord. It's how Chord really is able to deliver additional value, is able to scale in new ways. It's able to hit price points that you can't hit in other ways. And you're going to see, I think, a lot more of this moving forward. So that was ONAP. I'm going to touch on how we relate to ONAP. I want to do one slide on OP-NFV. How many of you have heard of OP-NFV and feel like you know what it is? That's pretty good, actually. So OP-NFV and Chord, I get a lot of questions about the intersection point and how they're different and how they're the same. I want to just compare and contrast them on one slide to help set the context. So, first of all, we kind of both started off in some ways after the same space, virtualization in the operator telco space, right? So we have that in common. Addresses the needs of the NFV space, at least is trying to help move the industry forward there. Makes sense? The next, of course, is that we both leverage many open source projects. We both leverage OpenStack, Linux, all that, and that's how you are able to really move the needle in the open source space. Is you don't have to build everything from scratch. You can build on what's been done before. But above this, it starts to deviate. So, OPNFV is around building NFV infrastructure, NFVI. And OPNFV is about providing lots of different options. So if you want a combination of, you want VMs, or you want containers, you want OpenStack, you want this controller, you want that controller, OPNFV will give you all those different options. Versus Chord, Chord's all about putting together a solution. It's back to the pieces of a car versus getting a car, right? So OPNFV will give you 7 choices of tires, and you can put it together. Chord is, you get a car, but you get a single pre-integrated platform, and then that's very easy to extend that platform and build and customize above that. OPNFVs, VNFs are out of scope. You don't get VNFs. You're getting the infrastructure, but you can build your own VNFs. Chord, the VNFs are in scope. We're trying to build a solution, right? So, OPNFV, you get the pieces, but you don't get seats for the car. Chord, you get a full car, right? And then with Chord, you can add your own VNFs. You can replace VNFs. Some of the VNFs we do, maybe they're too lightweight. They don't have the features you want. So you take one out, you put something in. But again, you start with the car, you see what doesn't work, you can customize it for yourself. And then OPNFV, it has 63 different scenarios. All these different combinations of pieces you can use, right? But what this means in practice is if the 2 vendors tell you they have an OPNFV compatible VNFs, each one can be running on one of 63 different combinations of a platform. So there's no indication that the 2 will run together. So it doesn't really give you an assurance that things are coming together. So it's a way of giving tools to vendors so that they can pick one of these 63 platforms and start building VNFs on top of that platform. That's really what OPNFV is providing, which has value, but it's not necessarily a unifying effect. Versus Chord, where you get one platform. It's one solution, one car, and then with 3 different solutions, for residential, enterprise, mobile. And so these are how we see, similar, different, and actually, we're actually working on, there's a group within OPNFV building lab infrastructure to be able to support Chord. Think of it, Chord is like one scenario, uses one scenario of OPNFV and can build complete solutions. If you take an OPNFV lab and you put in access hardware, you can actually run Chord on OPNFV. And so that's, I think it's called the Edge group. I'm blank, but look for that or email me and I'll help connect you if you're interested. So those, switching gears again, we have something that we're announcing here today is, part of moving the ecosystem forward is doing sessions like this, but also realizing that there's an educational need across the industry to help people understand this new space, this cloud-native technologies, and both vendors and operators alike need to level up skills. And so this is within our charter. We as an organization are trying to help drive and further this. And one of the things we are doing is something called Chord Learning Labs, which are online, virtualized, hands-on labs to be able to use Chord very easily and get trained up and bring skill levels up across your organizations, for you personally, for your organizations, to help drive things forward. And so we have this with a partner, one of our member companies called Criterion, and we're announcing this Chord Primer Learning Labs. These are hands-on Chord learning labs for skills development. It's hosted and developed by Criterion, as I mentioned, but we've been working with them and helping them. And then it's an online subscription-based model where you buy a licensed seat for one of the modules. You get, it takes roughly 4 hours per module to go through the training, and you get a whole virtualized environment. It fires up a whole Chord data center for you and then walks you through making modifications and learning about Chord and how it works and what makes it work. And I'm not going to go through in any great detail, but these are really the 3 labs. This deck is made available, I think, right after this presentation online, so you can find it. And the first is really taking people really from SDN technologies all the way up through ONOS, then things like OpenStack, and bringing that up, and then you start to really get into Chord and start to bring up containers and subscribers and whatnot. And it's intended to be a kind of a sequence of hands-on learning experiences in a real working live environment, but all virtualized and remote. Okay. So, and we just want to say, we're opening it up for beta today. The intention is to have a relatively short beta period, and for a certain number of users we need some feedback from people who have never seen this before, don't know anything about Chord. So I'm hoping to recruit some people here too. The way we're planning to do it is to limit it, to offer it at a greatly reduced price, but then also a full refund for anybody that actually provides feedback of these So we want you to try it. If you do it, you go out and you fill out a survey. At the end, we'll get some feedback. We'll even give you the money back. We just want to get some traction. Part of it is we want to test the payment process at the front end, and part of it is that we just want people to have a little bit of skin in the game, so they'll actually go through and run the labs and give us feedback. And here's a link for it. And then lastly, in the last few minutes, I want to point out that we have a demo that's going on here that's very exciting, that we announced last week. We did a webinar that you can look for. You can find a lot more on our website. So P4, how many of you know P4? P4. So that's about half as well. So P4 is really viewed as the best candidate for the next generation of the open data plane, the next generation of OpenFlow. Maybe. So think about this chart that we looked at the beginning, and for the major initiatives that have come out of the ONF, right? P4 is really focused on this spot in this vector of initiatives, and P4 is emerging as a follow-on for OpenFlow. P4 enables much greater, true programmability of the forwarding plane in the network versus just being able to configure and control the data plane. In this other diagram that we looked at, this chord diagram, P4 has the potential to really transform this fabric. Remember, this fabric is where we're starting to run elements of the service to be able to do VNF offloading is another way to look at it, but take functionality and push it into fabric. Well, P4 has the potential to really transform, make that fabric programmable, so you can really adapt the fabric for the applications and for the environment. And so what we're demoing downstairs, it's in booth A4 downstairs, really shows ONOS going to the next generation. So this is where ONOS is today. The SDN controller, the leading controller for operators, uses OpenFlow to talk to the pipeline, the data plane. But the pipeline is defined in ASIC and is a fixed set of functions, sequential steps for processing a packet before forwarding. And OpenFlow is used for managing the tables to configure that pipeline. And we've had years of OpenFlow now, and what we've learned is that OpenFlow started up as very simple and graceful. It was kind of a neat, packaged up kind of thing. But over time, we realized that there are multiple ASICs, multiple pipelines, multiple protocols, and OpenFlow got more and more and more complicated. And with all that complexity, what happened is OpenFlow, the seamless compatibility between a controller and the data plane didn't pan out over time. And in reality, that the controller, we've learned, requires tweaks for the variations in the pipeline. And so it's not trivial to just swap out the pipeline like that. And so what we are demoing downstairs is really using P4 in this space. And so P4 is about taking a P4 program that defines the pipeline. P4 then can be run through a compiler. Then the output of that compiler creates components that can get downloaded to program the data plane, and also to be able to be picked up inside ONOS to be able to communicate to the data plane. So all the semantics of the data plane are automatically imported into ONOS, and then the interface is basically defined between the two environments. And so in this way, the controller can dynamically change the data plane, and then through this compilation tool chain, picks up all the capabilities needed to know how to manage that data plane. So this is very exciting, very, very exciting. But also, it's really important to note that there's an application even when you don't have a programmable data plane. And what that looks like is leveraging this for a fixed function data plane, where you still have fixed function here, but instead of using P4 to download the capabilities into the data plane, you use P4 to document the capabilities of the data plane. You extract a definition of the data plane into P4, and then you still run it through the same tool chain to be able to program it, to tell ONOS how to be able to communicate to that data plane. So we believe this is also a vehicle for being able to add much more seamless compatibility between the controller and swapping out elements of the data plane versus the problem spots we've experienced with OpenFlow in the past. So I invite you to come down and see the demo. Booth A4, it's down right by registration in the front. We have three organizations that have been working together on this. ONOS, which is inside the ONF, is the open source controller. Google and Barefoot. So ONOS is using P4 downstairs to manage the spine leaf fabric. Google has contributed the P4 program that's being used, Tor.P4, to define the pipeline. And Barefoot has has contributed their switching hardware, which is hardware that has the capabilities of supporting P4 in hardware in their chipset, and then we have systems downstairs, all configured in the spine leaf fabric. Plus, we also are running it on a soft switch that's open sourced as well. So as part of this now, you can get a full end-to-end open source distribution to be able to start to experiment with yourself. You know. And then lastly, you know, I just want to share sort of the end vision a little bit of where this goes for Chord. You know, it's kind of started, virtualization started with this notion of taking functions out of a fixed function router and putting it on an x86. I mentioned that earlier, you know. And what really resulted from that were these monolithic VNFs, these big, huge footprint VNFs that consumed a whole server, and they're very expensive, and they really didn't pan out in terms of the economics. It wasn't much cheaper to take things out of a router and slap it on dedicated x86s. It was still like purpose-built in almost all the same ways. The next big step was microservices, and this is really where Chord has been, which is really taking functions and like a subscriber management, a BNG, and breaking it into all the little pieces, and then running it in a cloud-native way. And this is what Chord enables today with the R-Chord solution, and you'll hear more about that as we go on this afternoon. And with this, we've now started to achieve the economic crossover. And this is one of the reasons that Chord's getting the phenomenal traction that it's getting today. So the next big step is taking these fabric services I was talking about and really taking it to the next level. So, you know, microservices running on a server like x86 or ARM, and fabric services, and that are P4-enabled fabric services. Because now with P4, we believe we can do a lot more. We can push programmability into the data plane. We can take a lot more functionality, push it into the data plane, and achieve really big breakthrough kinds of price performance things. And you know, really, the end result here is 100x performance improvement. That's 2 orders of magnitude. I mean, that's enough to really change the industry. And we're already on track here. I already mentioned that we've already done some of this using OpenFlow for certain functionalities within Chord, and we think that there's more to come. And so we're very excited about that. So with that, I want to just thank you, and I think we have a little bit of time for questions. You know, 2 minutes. Yeah, please. I think there's a microphone. Well, you might have.
So this is Oz Argela. So some of the use cases you mentioned at the beginning are also applicable to multi-edge computing. So MEC and Chord, are they competing or complementing? Yeah,
that's a great question. And we don't talk about it enough, but you know, so MEC, M-E-C, which started with mobile edge computing and then got rebranded as multi-access or edge computing, is basically putting compute at the edge of the network in one form or another. And MEC is really going about it in trying to find ways to connect things into the mobile network, how to terminate GTP tunnels, be able to process it and tunnel it back in, doing all this complicated stuff. In our view, Chord gives you all of that. Gives you everything you need to be able to do multi-access edge computing, MEC, and natively, by pushing these edge clouds out there. And so, in some ways, we don't even talk about it as a separate thing. It's something you get for free with Chord, is our belief. It gives you all the benefits of MEC and more. And so we think the concept of MEC is consistent with our view that you need to be able to do processing at the edge of the network, but we just have done it in building native clouds rather than trying to hack together things so you can insert processing in the existing flow of proprietary boxes. Think of it that way. Okay. Good question. Thank you for the question. Yeah.
I'm Amir Atai with Corient. First of all, great project. Congratulations.
Thank you.
So I started with central office 32 years ago, and I've built the startups on cloud, so I've seen this cycle. One question I have, I think service providers will have the competency to build Chord, no doubt, because they're very good in building this kind of technology. But when it comes to applications, and you mentioned several of them, virtual reality, just think of any applications. Service providers have been terrible in offering creative application from the network. So that's going to come from little companies, third-party apps, and so forth. So in your projects, how are you going to handle the fact that real applications are not going to come from service providers?
Yeah, that's a great question.
They have to come from third-party and that environment.
Yeah, no, great question. And I agree with you completely that, innovation comes from smaller companies and whatnot. And so, a big part of our organization, as I mentioned, we have over 160 plus members. We have a whole process called an open innovation pipeline to be able to let small companies bring innovation in, like a VNF or a service or a white box or a barefoot with a forwarding chip, and integrate it into solutions that are getting consumed into field trials. And so it's a big part of our whole vision. It's called the Open Innovation Pipeline. I encourage you to just Google that. Come find me after this. I can help anybody plug into that. And it's basically our vision for how to drive the ecosystem, enable the ecosystem to do exactly what you described. Because we think it takes all kinds of players and takes a community to build these solutions. So we're absolutely agreed. Okay, so I think I'm out of time, but thank you very much. And I'm here if there are questions afterwards. Thanks.